Good day, students. In this clip, we're going to be going over two examples on how to simplify exponential expressions. So the instructions for the examples are as follows. We are to simplify the following exponential expressions, expressing their results as rational exponents and radicals. All right. So let's take a look at the first example. Number one, we have the third root or the cube root of 27x to the 6th y to the 5th. Okay? All right, so first thing we want to do when simplifying rational expressions is you want to express the radicand or the argument of your radical expression as in exponential form every single term, and then you want to express your radical as irrational exponents. Okay, so if we take a look at 27, we can break down 27. Let's break that down on the side. 3 goes into 27 9 times. 3 goes into 9 3 times. So if I want to express 27 as a product of prime exponents, I'm going to have 3 to the third power as 27. Okay, so this enables me to simplify completely. All right, the other variables are already in exponential form, so this expression can be written as 27 in its prime exponent form is 3 to the third times x to the 6th, y to the 5th, and when we use the special case of the nth root property, actually no, just the nth root property, we apply the nth root property here, we're going to have this to the 1/3 power. All right, what we're going to do next, we're going to use the power of the product of powers property to simplify this expression. So what does that involve? We have to distribute the power to all these powers. We're going to multiply them, okay? So I can express this as 3 over 1, 6 over 1, and then 5 over 1. When you're multiplying fractions, numerator goes to numerator, denominator goes to denominator. All right, so we're going to have 3 to the 3 over 3 times x to the 6 over 3 times y to the 5 over 3. Okay, now we're going to take a look at each rational exponent, and then we're going to see if it can be reduced. All right, so let's take a look at the first one. 3 over 3 can be reduced to 1, so this is 3 to the first power. And then 6 over 3 divides out to 2, so it's x to the second power. And then we have y to the 5/3. Okay, so if I want to express this expression in as rational exponents, I can write it as 3. There's no need for a 1. If the exponent is 1, you don't have to put it. 3x squared y to the 5/3. Okay, so this is your answer as rational exponents. Okay, so there goes that, and then let's identify what type of result this is. This is rational exponents. All right, now there's the question calls for us to express the answer in radical form also. Okay, so how do you express this in radical form? Any exponent that's a fraction should be expressed as a radical, should be converted into radical form. Okay, so we have 3 to the first power. This is an integer, so it cannot be expressed as a radical. X to the second is an integer, cannot be expressed as a radical. But y to the 5/3 can be expressed as an integer and a fraction. Okay, so in that case, we're going to have y, if I want to write it as a mixed number, 5/3 is 1 and 2/3. All right, so the integer part cannot be written as an exponent, but the fractional part should be written as a radical using the fractional exponents property. So let's go ahead and break it down. So we're going to have 3x squared, that remains untouched. Now I'm going to write this as y to the 1 plus 2/3. Okay, we know 1 plus 2/3 is 1 and 2/3, which is 5/3. Now if you think about, there's a property that results in the sum of the exponents. What property is that? Well, that is the product of powers property. So we use a reverse of the product of powers property. This can simply be written as 3x squared times y to the first times y to the 2/3. Because the product of powers property tells you that if you multiply two exponents of the same base, you add the powers, okay? So if you have a sum of powers of a base, you can express the base as a product of the two addends, all right? So that's what we have here, is the reverse of the product of powers property. All right, now remember, if you have an integer exponent, it cannot be expressed as a radical. Only the fractional exponents can be expressed as a radical, all right? Now, this can be simplified into 3x squared y. Now, if we use the fractional exponents property here, we can express this as the square root of y, the cube root of y to the second power. Remember, the denominator is the root and the numerator is the power. So there goes your result as a radical. Okay? So this is the result in radical form. Let's write that down, radical form. All right, let's shift our attention to question number 2. So for number 2, we have to simplify the exponential expression, the square root of 288 x to the third y to the fourth times z to the fifth power. Okay? All right, so these three variables are already expressed in exponential form. Now we need to express this number 288 as a product of prime exponents, all right? So to accomplish that, we're going to find the prime factor decomposition of 288 and then express them as a product of exponents, all right? So since this is even, I can extract a 2. 2 goes into 288 144 times. And then take out another 2. 2 goes into 144 72 times. Take out another 2. 2 goes into 72. 2 goes into 7, 3, 12, 36. 2 goes into 36 18 times. 2 goes into 18 9 times. And then 3 goes into 9 3 times. Okay? So if I want to express 288 as a product of prime exponents, I have 1, 2, 3, 4, 5, 5 2s, so that's 2 to the fifth in exponential form. And I have 2 3s, which is 3 to the second power. Okay? So now I'm going to express this as a rational exponent. I'm going to be using the special case of the nth root. So if I express 288 as a product of prime exponents, I'll have 2 to the fifth times 3 to the second. And then we have times x to the third, times y to the fourth, times z to the fifth, everything raised to the 1/2 power, using the special case of the nth root property. All right, now I'm going to distribute this 1/2 to all the powers. I can express them as fractions. Reduce where I can, and that will tell me the result in rational exponent form. All right, so this becomes 2 to the 5/2 times 3 to the 2/2 times x to the 3/2 times y to the 4/2 times z to the 5/2. All right, so let's see which one can be simplified. Now, if you take a look at the numbers, 2 to the 5/2 cannot be simplified, so we can leave it as 2 to the 5/2. 3 to the 2/2 can just be reduced into 3. Now, if you take a look at these variables, in the reduced form, this one stays the same, x to the 3/2, and this one becomes y to the second power, and this remains z to the 5/2. Now, anytime you're taking the even root of a variable expression, the variable can never attain a negative sign. If it attains a negative sign, then you're going to have imaginary numbers, which is not in the domain of a radical function. All right, so what you're going to do is you're going to take a look at these three variables, and you have to enforce positivity. You have to guarantee that these three variables can never attain a negative value, because when you take the even root of them, you're going to end up with imaginary numbers. All right, so the question is, how do you enforce positivity? Now, when you take the even root of any variable expression and reduce the exponents, if the numerator of the exponent is odd, or the exponent is odd, then you have to enforce positivity. Okay? So how do we do that? Now let's look at the x term. All right, I want to make sure that x is positive. So I look at the numerator of the rational exponent. It's odd. Okay, so that means this variable can actually attain a negative value. So to enforce positivity, what I'll do is I'll add an absolute value bar right here. Okay, so adding an absolute value bar guarantees that I will never have an imaginary output. Now let's shift our attention to the y square. Y squared, this is an even number. Okay, so if it's even, you don't have to bother, because when you raise a negative number to an even power, it cancels out the negative. So this square enforces positivity here, so we don't need absolute value bars. Now let's go to the z component. You focus on the numerator or the exponent as a whole. This numerator is odd, so this variable can attain a negative value. So we have to enforce positivity here also. So we just add the absolute value bar right there. Okay, so there goes your final solution. Let me rewrite it. So as rational exponents, this can be written as 2 to the 5 over 2 times 3 times the absolute value of x to the 3 over 2. That guarantees that x can never be negative. That you never take the square root of a negative number, times y squared times the absolute value of z to the 5 over 2. Okay? So notice how you put the constants first, and then you put the variables in alphabetical order. All right? So this is your result in rational exponents form. So this is as rational exponents. All right, next thing we're going to do is express this as a radical. So let's go ahead and express this as a radical. Now remember that fractional exponents have to be expressed as a radical, but if you have an integer exponent, it does not qualify to be written as a radical. All right, so 5 over 2 is an improper fraction. We have to express it as a mixed number, so we can separate the whole numbers from the fractions. So 5 over 2 is 2.5. Okay, and then we have times 3. This has a power of 1, which is an integer, which is okay. We don't need a radical around that. And then we're going to have the absolute value of x to the 1.5. Okay, and then y squared, we don't bother with that because it's an integer. And then the absolute value of z times 5 as a mixed number is 2.5. All right. Okay, so now we're going to separate the fractions, so we can use the reverse of the product of powers property. So we're going to have 2 to the 2 plus 1/2 times 3 to the first power. And then for the x, we can split that apart. 2 is going to have absolute value of x to the 1 plus 1/2. Y squared, we leave that alone since it's an integer, times the absolute value of z, 2.5, 2 plus 1/2. Okay? So using the reverse of the product of powers property, since we have a sum of exponents, we can express it as the base with these add-ins as their exponents. Okay, so we're going to have 2 squared times 2 to the 1/2. Remember the product property of exponents, if you have the same base, you add the powers. Okay, so using the reverse of that, times 3, leave that alone since the power is an integer, times the absolute value of x to the first power times the absolute value of x to the 1/2. Same idea we are applying here, times y squared. Now if we break this up, what is it going to look like? It's going to be the absolute value of z to the second power times the absolute value of z to the 1/2. Okay? Now the nice thing about this problem is all the fractional exponents have the same exponent, 1/2. If they had different exponents, if they had different values, then what you do is you just simply find the LCD of all three of them so you can combine them into one. Okay? So they all have the same exponent, so that's perfect. So what we're going to do is separate them. Okay? So let's extract the numbers, the terms that have integer exponents. So this is an integer that's an integer exponent, integer exponent, integer exponent, and integer exponent. So let's separate that. 2 squared is 4 times 3 times the absolute value of x times y squared times the absolute value of z squared. Okay? Now the terms that have the fractional exponents, let's put them next to each other and see what we can do with that. All right, so we're going to group them in the parentheses. We have 2 to the 1/2 times the absolute value of x to the 1/2 times the absolute value of z to the 1/2. Okay? Now to combine this, we're going to use the reverse of the power of product of powers property here. We're going to factor out these common exponents that they have. So this, the portion on the outside becomes 12. 4 times 3 is 12. Times the absolute value of x times y squared times the absolute value of z squared. And then here we have 2 times absolute value of x times absolute value of z. And then we extract all the exponents raised to the 1/2. Okay, so we have it like that. All right, let's simplify this further. So this is going to become 12 times the absolute value of x times y squared. Now, if you notice this z right here, after separation, it has an even power. Okay, so since it has an even power, there's no need to enforce positivity here, since this square will take care of any negative. Okay, so we can just express this as z squared. Now, over here, using the reverse of the special case of the nth root property of exponents, I can express this as the square root of, now anytime you take absolute value and express it as a radical, there's no need to keep the bars, okay? So you just express it as 2xz, all right? So there goes the radical form of the original expression when it's simplified, all right? So this is the radical form. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel. You can comment to let me know what you think about this clip. Click like if you liked it, and feel free to share with your friends via your respective social networking program. More math clips come from mathgotserved.com. Thanks again for watching, and have a wonderful day.